How's it going, everyone? Welcome. Gabriel Gonzalez here again to recap and finally to wrap this model of rendering logic of CSS as a way to understand now how is that CSS works, and especially for a pragmatic sense in JavaScript, right? What are the things that we need to understand in order to make it practical as a JavaScript developers? Because of that, well, I make or Josh Camille actually make a pretty good course that also now points to other things. This is part of my own research in terms of now understanding is what is where this coming from, right? By looking at the um, W3C or the CSS spec, right? But the TLDR is that on the Model Zero in this uh, course from Josh Komiwa, a software engineer uh, that previously worked at Khan Academy as well as Gatsby. When first thing first, we need to at least understand is the current state of stuff to be effective in 2025. All right, and that is what is CSS, um, what is the anatomy of CSS, how you can add styles like inline external style sheets or inline style sheets or internal or external style sheets or inline styles, how you can now select elements to apply now these particular rules to describe how it's going to look, and it is so the geometry and its position, uh, and the combinator of those selectors. We can also have the base state selectors, uh, which is defined based on some user actions that happens or some events that happen in CSS. All right. Also, the functions that the language provides to do some common stuff. So, for example, is to define the transitions or to calculate something, which is the most is the things that I want that I'm the most common of, or to now compute is the color as well. It also is the rules in which now CSS will behave in specific scenarios. So, for example, hey, I want you to now define a layer, and therefore, this is the rules that I want you to apply, right? So, for example, in these particular layers, this is how I want my UI look like. So all of these elements look like in the position for mobile development, or for the mobile or tablet or desktop, right? Or 4K screens. And also some other behaviors, like for example the transition, the keyframes. So how these rules will go to so what is the values from this property, CSS property, will among a timeline, right? The keyframes. And also is that how this content will behave when there is a particular media point. So it also to understand is the shorthand property that we can use as to describe is the box model. But before going into that, at least to understand is what are the things that we need to get used to this, which is first understand what are the CSS rules and the declarations. Second, what a media query is and why still we need to understand this, because it's quite relevant. Also, the pseudo elements or the selectors and the most common selectors. So, for example, is well, pseudo selectors most likely, like pseudo class selectors. Uh, so, for example, is the hover, the focus, the first and last in child or in type, and why, for example, the first last child, and the focus is quite relevant, especially on web accessibility, which is another realm, is part of the realm of HTML, CSS, and JavaScript, and accessibility, which is, hey, we want to make your content now accessible for a wide audience. So, on that topic and this accessibility here, there actually is stand of four principles. So you have is the perceivable. It stands for poor, which is quite weird acronym, but in any case, which is, hey, if this element is perceivable, if this is operable, if this is understandable, right, and if this is robust. And now how certain CSS selectors or elements actually follow specific uh, recommendations. Okay, so based on this web content accessibility guidelines. So another thing that we need to know is what are the common pseudo elements that we can use. So, for example, placeholders, uh, in the after and before when it comes to now add some uh, elements or useful for animation or for decoration. Okay, also to understand is the color formats that we can use. Color is in itself a realm that is huge. My bad. I'll be right back. All right, and we're back. Sorry, my bad. Um, but yeah, I just wanted to make a quick recap of this, or at least the model zero. When we look at the things that we need to know in order to understand now the CSS, and how now, and what are the practical, so what are the key things that we need to know in order to be effective with JavaScript, particularly when it comes to work with a React application, or to describe the UI using a, a React framework. Okay, so as I mentioned before, we also look at the color theory. Why it is important to understand is the color formats, whether it's keywords for educational purpose, or RGB, hexadecimal, and how HSL is way much more intuitive to compute a color. So also the units that we're gonna use here to describe is this dimension and the position, such as m, root m, pixel, and percentage. And why percentage is something that is used to compute is the width or height for to to compute the width of the height of an element as a box, and understand now the typography. So, for example, what typography is, with the type of typography that we can have, sans serif and serif, and also it is variants of this typography, which is the italic, bold, and because these applications that we're building, once we want to provide now unique experience, well, we have now custom tailor or custom apps, uh, that or custom fonts here. So we have now custom fonts that allow us is to provide this unique experience. So this is known as the web fonts. And also to understand now is like the things that we can do with text, the operations with that. So like text alignment, text transformations, text spacing, whether it's line spacing or letter spacing, and also is uh, the the text transformations, the alignment, and the spacing. So all of this is just the basics, the fundamentals. And then once we look at the rendering logic, which is the core of the CSS and how that fits into our entire web development, uh, first thing first is to understand that all browsers comes initially back in the old days and currently right now with their own set of style sheets, aka the user style sheets. So because now here as more browsers adopt the W3C spec, the CSS spec, where they describing is how these elements should look like, because that was not all because this was not always the case. Well, it turns out that we have to use something called a CSS reset as a way to make now all browsers that where we're going to run our code be in the blank state. All right. So this CSS resets that has evolved over time because most browsers, as I mentioned, now they have follow is the CSS spec, but there's some of them that vary across that. And one of them, for example, is the box model, or how the width and the height is going to calculate it here. And speaking of this box model, which is part of this is the visual representations of how the elements into a document, aka the DOM, will look like in printed in visual media, all right, such as the screens. This is also something that mentioned on the spec, right, with the box model. And to me, that's quite revealing here. When I read about that, when I definitely read about this. So, but in order to understand now this, how this fits into our entire narrative here, to understand is in a more practical sense, is that uh, browsers so browsers comes with all of this varying of CSS known as user style sheets. So in order to make them act as a single blank state or have a common ground, we have these CSS resets. And CSS resets is just a CSS declaration that we now define, right? So our designer have defined for that. So because some property can be passed down or inherited, most likely text-based properties, in order to know for CSS which competing rules with the same name will be applied or which CSS properties will need to be applied, we look at this cascade mode, which is a set of different tiers that determine uh, what will be is the styles to be in the what what will be the style to be applied on the document. So this tier is like a cascade. So the further it goes down, the less likely is to be applied on the DOM or the document. So we first look at the importance. So for example, keywords like or properties like translation or important or even animation as well. And then where that rule is located, whether this is at the application level, or this is based on the user or the browser that provides. And the other is that a specificity of those selectors, whether it is if this is an ID or if this is a class, an attribute, if this is a class, all right, or if this is now a class, yeah, a class or a pseudo class, or if this is now a element or a pseudo element or a tag here. And last but not least is the order in which this style appear in the CSS, right? So the further it appear, the more likely it will be the more likely it will be applied into the DOM if there is no competing CSS. So this is just to understand at least the notion of CSS, because it's explain what is coming next. Okay, despite that it is not required for us to understand that, but at least it will give us a sense to when it comes to define all of this user interface, understand what's going on behind the scenes and defining this content, because traditionally this come from most of this content come from the print media, from Gutenberg, so on and so forth. The way how we describe this content is whether it's inline, which is the direction of how we read the text, and the block, which is a group of this bunch of words into a paragraph, right? So this is known as position directions, which is something that when you want to align a document, we use now, for example, is the margin or the border or the padding to actually align, but based on this uh, location. But because now the content can be present in different cultures, so whether it's not only Western cultures, but also is the Middle East and or the hands-based characters, for example, like Asia and the Chinese, Japan, South Korea. So because of this, now the CSS3, the CSS working group has shown now that we can go and work with these logical properties, that it makes much more sense and that aligns to how the text is going to be read, right? The document directions, or the content direction, whether it's a block or inline. So in order to understand now this content and how they're going to be positioned, all right, so the box model is, as I mentioned before, is a way of how now CSS treat elements into the document via this box for visual screens. And don't take my word for that, because you can see box model here and the CSS and the spec. All right. Diggy. There you got a CSX box model. And again, also another thing of this is to get ourselves familiar of how we're going to read about this. Okay, but this is a draft. Latest published version is this is a working draft, editor draft, working draft. I do think it's this. So, but it's to illustrate this, the abstract. This is spec describe the margin and padding property which creates spacing around CSS box. But this is not really okay. CSS is a language for describing the rendering structure, such as HTML or XML, on screen, on paper, and etc. Right? Um, CSS describes how elements on each string of text in a source document is laid out by transforming the element tree into a set of boxes. Again, for print media or for screens or paper, whose size, position, and stacking level on the canvas for all media. The term canvas describes the space where the formatting structure is rendered. So, for example, is the viewport. The canvas is infinite for each dimension of a space, but rendering generally occurs with a finite region of that canvas, established by the user agent, aka the browser, according to the target medium. For instance, user agents rendering to a screen generally impose a minimum width and choose an initial width based on the dimension of the viewport. So user agents renderings to page generally impose width and height constraints. Aural user agents may impose limits in outer space, but not in time. That's interesting. So when they talk about is the canvas is this infinite dimension of the space, but rendering in the context of here is when now this unprocessed raw data or this unprocessed raw inputs is going to paint so this unprocessed raw inputs is produce a ready to be used output, aka an image here. Okay, the canvas. So, what is this? CSS describe how elements of each string of text is in a source text is laid out by transforming the element tree into a set of boxes. So whose size, position, whose size, positions, and stacking levels on the canvas depend on the value of their CSS property. So in order to now understand that, which is describing is this, and pretty much with the box model, all right, because now this box you can think of is like a winter layers, which you put several stuff on that, and each one of those layers, so for example, you as a person, and the code, the material of the code, and then the thin material of the code, and then the exterior, right? This can be thought now as the box model. So this box model is a way of how now, by describing this anatomy of the content, the padding, and the border, as well as the margins, and how it works when it comes to define is the and how this text is going to be look like on the screen or on paper. So is this particularly anatomy? First we look at the padding, all right, which is allow us is to adding is now is convenient space around the content. What are the properties that we can use? The shorthand property as well, and also look at the border and how now in the border we can. This is different from the padding and then the margin. So the border allow us is to now first by default define is what is the border width or the border line or the border style here. So first you pass is the border style. So first you pass is the border width, and then the border style, and then the color. And also you can define is it is corners of this, and the difference between the border and the outline, which border is now considering in the calculation of this the um, of these boxes, but outline does not. And how now outline is used, for example, is on focusing elements, right? So, and the other is the margin, and how in margins, it has some funny behaviors when it comes to describe is how these elements will behave and how they're gonna look like, right? So, margin in itself is a way for us to say uh, how these elements, what is the space around these elements, the gap between these elements. And this gap is horizontally. So, because and this gap can be is horizontally or vertically, right? We can also now overlap is margins with these negative margins. Uh, and when it comes to understand now how this box behaving related with another boxes, okay? So there are now different contexts in which they can be rendered, right? So this context or stacking context or context rendering, or particularly is the visual formatting, as they mention here. Okay, this visual formatting, which is something that they don't describe here because this is not right. But the visual formatting model, if you take a look now at the visual formatting model here, okay, is describe how user agents take the document tree and process and display it for media. And this includes continuous media such as computer screen and page media such as book or document printed by browser print functions. So more information apply equality to continuous and page media. In the visual formatting, each element in the document creates 0 or more boxes according to the box model. So this layout is governed by box dimension and type, position scheme, relation between elements in the document tree, and external information. Much of the information about the visual formatting model is defined in CSS2. However, various CSS layout mode has expanded upon this information. But this visual formatting model, okay, is describing is how user agents takes a document and processing and display it for visual media. So, because this um, uh, visual formatting model that produces blocks or that produces these boxes, so how they relate each others and how they calculate it and how they position here is based on this visual formatting model. Because this relationship of this box in JavaScript, in CSS, we have now different layout modes, aka different way of how we can position these elements. First, we look at the most in common and the default one, which is the normal flow. So this normal flow that yes, so this normal flow, okay. Mm-hmm. Uh, this normal flow, which is describing is that how now all of these boxes will behave in this layout, the normal layout, all right, known as the flow layout, and we can have different layout as well. So you have now the box, so you have the normal layout, or the flow layout. We can also have the flex box, or the grid, all right, as well as the positioning, absolute. But again, all of this is uh, so we're focused. Our attention is on this particular layout, the flow layout. So this flow layout is made of two components. So elements here can be either is a block, inline, or an inline block. Okay, so a block is now, it takes all the available space, all right, horizontal space. Uh, so it actually doesn't line break, okay, and you can modify is the dimension of these boxes, so the width and the height. But there is another one which is the inline, which say, hey, let's going to now take all the available space, uh, and if that goes beyond the viewport, let's gonna line break this. So this is one of the cool things of inline, so it can line break the content, and also there's some other tags that there's some now by default uh, type of so some there's some groups that there's some HTML tag groups that belongs to each one of those type of uh, elements in this layout, whether it's a block or an inline. All right. So a block, so for example, is for for headings. Okay, anything that is a heading, a header, a section, a main, a footer, a div. Okay, and then you have the inline, which inlines, they don't make any fuss, right? In some elements like paragraph and span, I do think that it is what it is. I think it's like that. So paragraph and what's the other one? Um, yeah, paragraph and exactly. So paragraph and what's the other one? Diggy 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 diggy. So paragraph and a span, all right. So this is now, so paragraph, span, image, and video in Canvas, they are all treated as inline elements, right? And that's quite interesting because there's some edge corner here. So if you, for example, wants to now put several elements next to each other as an inline element, all right, and if you add some particular space, it's going to add that particular space next to it. This is one of the trade-off of using image. So you can remove that by just putting all of these elements next to each other. And the other is that because uh, image are treated like typography as an inline, all right, it add now a little space at the top that this is useful for the typography, but for image might not. So we can now remove that, whether it's by using is a line height of 0 in that particular element to remove that element. I do think that's quite interesting. This particular nuances of the flow layer, especially working with inline elements. And the other is the block inline or inline block, my bad. That is say, hey, now these elements, unlike now inlines, that you can modify it is dimensions, you can move is the position horizontally, all right. Now this image or now this inline elements doesn't allow us to is redimension it is shape, but what we can do with inline block is to reshape its dimension, all right? But unfortunately, we cannot line break that. So when it comes to now compute the width and the dimension of a box in the flow layout. So for example, with the width and the height, we looked at width. They have some particular properties. So if you're using percentage, what you're indicating is that hey, please grab is so inherit the or grab the parent height, the parent width dimension, the parent width value, grab it, and then apply some percentage based on that. But if you don't, if you use, for example, some keywords like max content or mean content, so you're telling is that, so you are affecting if now is at the children's here. Hey, from this box, I want the width will be is the max width, for example, which takes all the available space that these elements would have. If this is a max, if this is a mean height, or if it's a mean width, it's a hey, I'm gonna look all of the elements, all of the children elements here, and take the greater, and that'll be is the mean height, and that'll be the width of this element. And the other is the fit content. If you say, hey, now I want to make this content to fit inside of this box, right? So I do think that this is quite interesting in order to describe that and how you can do this. And the other is with the height, because now with height, the story is that instead of when you're using percentage, the way how now in the flow layout is determined, it is this is where my gap here. This is where my gap here. So in order to determine is the height of something, or to align something with the width outer, okay. Also, we tend to treat a height as more dynamic than width, and we might feel comfortable setting our main wrapper, our main content wrapper, to have a max width of this, but we wouldn't usually do this with height. We want our design to work whether the content is 200 words or 20,000 words, and even for page with the exact same content. We expect that our containers will grow taller on phone screens and shorter on desktop monitors. We generally want to avoid setting fixed heights, otherwise we might end up with situations like this, where we get this. So constraint height is generally a bad idea, because we usually don't know how much space the element's content will take up. For example, so defining is a height here is not a good idea. So when it comes to layout, wrappers like this, setting a fixed height is usually a bad idea. But what about when we want to set the minimum height? Okay, so for example, we say, hey, mean height. So, can I modify this? We say mean height is this. Okay. Is mean height is 100 pixels. So if you, for example, remove this content, so you actually now are setting is the mean height for this element, which makes a lot of sense. Or you can growth. All right. So for example, let's say we have an element that wraps here. But what about when we want to set a minimum height? Okay. So if we say 100% here, or 50%, okay. For example, let's say we have an element that wrap our entire app. Okay, an element that wrap our entire app. If a specific page doesn't have much content, the entire app might be less than 100, like this. Or of our window height. But what if we want to take at least 100% of the available space, right? So our goal is to have a wrapper element that will be no smaller than 100% of the available height. So, but mean height doesn't work. You can say, hey, mean height or 100, okay? Because it only takes in consideration, okay, mm-hmm. Or similar to this. So mean height or height, it only takes in consideration is the current content. Mm-hmm. Okay. So have you ever tried to use percentage based height only to discover that it seems to have no effects? And it's because height here is taking is the behavior here is that height is taking this small amount as possible to contain its children. Mm-hmm. Okay. So the height algorithm, if you want to, okay. So if you want to now compute is the height, all right. By default, the height is the small is it, so the height value is as small as possible to contain its children. But what happens when you want to, for example, is now set a mean height that include is the entire document, right? Or that wrap the entire document, or that wrap the entire view. So because of that, we can is now pass is the body, and inside of the body or on the HTML is to say, hey, the height here will be now 100% of that. It's because you have to explicitly tell now to CSS and to the browser that, hey, this is how can I look at this. This is a really common source of confusion. It isn't Firefox, it isn't fixed by Flex or Grid either. Those tools help us to control the content of a container, but that content still needs to get it hide from somewhere. Here's how you fix. You put hide elements on every element before your main one, including HTML and body. Put the mean height 100% of that wrapper, and don't try and use percentage based heights within that wrapper. When HTML is given 100%, it takes all the height of the viewport that serve as our base. The body tags 100% is based on that base size. Because we are telling now to the browser, hey, I do want to take now all the available height of this viewport. Mm-hmm. And here is in the code like this. So for other applications or for other wrappers, for other frameworks out there, JavaScript frameworks like React, this is for the Create React app, and this is for the next. Mm-hmm. Okay. Mm-hmm. 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 Okay. 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 Mm-hmm. Interesting. Very, very, very interesting. Mm-hmm. Know that this isn't specific to React, and we need to include selector for every element that sits between the root HTML tag. We want to stretch on to 100% of the screen size. But yeah, I don't want to distract from the fundamental key takeaway, from the fundamental takeaway here, because it is a really important one. By default, width looks up the tree. By default, width looks up the tree, while height looks down the tree. Exactly. So in order to compute that in the flow layout, all right, or in the computation of width and height, so by default, width look up the tree to compute that value, and height looks down the tree. An element width is calculated based exactly. An element width is calculated based on its parent size, but an element height is calculated based on its children. When it comes to heights, a parent element will shrink wrap itself around its children, like a pouch of vacuum sealed food. Mhm. Like a pouch of vacuum sealed food. Of vacuum sealed food. Pouch. Um, like a pouch. Like a pouch of sealed food. Mm-hmm. Okay, like a pouch of vacuum sealed food. We can override this default behavior by specifying an explicit value. For example, width 300 pixels and height 500 pixels. They'll look up down the tree and they don't have to calculate anything. Since we are giving it a specific value, so I'm specifically talking about when we don't set width and height. Mm-hmm. Exactly. When we don't set the width and height, the width will be determined of that element by its parent, and the height will be determined is by its children. Okay, okay. So when it comes to height, when there is no specific values, okay, it is value will be determined is in that. So a padding element will string wrap itself around its children, like a pouch of vacuum seal food. Hmm. Hmm. What about the VH unit here? You may be familiar with the VH unit, which is the view height board, a unit designed exactly for this purpose. If you set height to 100 view height, your element will inherit its height from the viewport size. Exactly. Unfortunately, this unit doesn't quite work the way we often like because mobile devices. So when you scroll on a mobile device, the address bar and footer control slide away, yielding their space to the content. This means that scrolling on a mobile device changes the viewport height. That scrolling on a mobile device changes the viewport height. To avoid flickering UI issues, browsers like iOS Safari and Chrome Android will set the view age equal to the maximum view height after scrolling. This means that when the page first loads, 100% will actually be quite a bit taller than the viewable area. If you want to set this for yourself, here are some demos. Give them a shot on your phone. Sure, sure, absolutely. Let's get into this. Mm-hmm. Okay, let's get into this. Absolutely, absolutely. Mm-hmm. Hmm. Let me do something here pretty quickly. Let me actually is test this. Mm-mm-mm. Diggy diggy. Mm-hmm. Oh, come on. Mm-hmm. Mm-mm-mm-mm-mm. When you scroll on a mobile device, the address bar and footer controls fly away. This means that scrolling on a mobile device changes the viewport height. These days, there are new units that we can use that don't share this problem. This unit is available across all modern browsers, but still is a good to provide a fallback for older browser. And the other is this. In full height percentage. Mm-hmm. Mm-hmm. And this full height percentage is now. Look at this. Exactly, this full height percentage. Unlike this, which is using 100% view height. Okay. Holy moly, bro. Okay. Yeah, damn it. In particular, this SVH unit, small view pore height, will always correspond to the shorter viewport size, the initial condensed viewport. So when so this VH unit is designed exactly for this purpose. If you said that, your elements will inheriting it is that. But unfortunately, this doesn't work quite well for mobile devices, because when you scroll on a mobile device, the address bar and footer controls slide away, yielding their space to the content. This means that scrolling on a mobile device changes the viewport height. To avoid flickering UI issues, browsers like iOS Safari and Chrome Android will set the VH equal to the maximum viewport height after scrolling. This means that the page first load 100% will actually quite a bit taller than the viewable area. And in order to fix this, you might use the small view height, but this is for mobile. Earlier we talked about the common UI challenge of having a footer that stayed at the bottom, like this. Having a full height container is an important prerequisite, but haven't seen the tool needed to finish solving this problem. Ultimately, the goal with this model is to get comfortable with the height, like this. But we can use this as a flexbox to do this. But the TLDR of all of this is that height, width, and height by default, the first lookups up the tree, and the height looks down the tree in order to compute its value when there is no when you don't pass value to that. That'll be all for this video. Take care. Bye bye.